welcome everyone. I am Sandeep Dolai. Today I am presenting our PBL project, Mobile Smart Charger IoT Device. I am the student of GMU University Davangere, Department of Cyber Security. My teammates are Samina, Shalini, Varsha, Shreya and myself. Our project guide is Mr. Kotresh SN, Assistant Professor of GM University, and our project coordinator is Naina MR, Assistant Professor of GM University, and our HOD is Dr. Arun Kumar Sir, Assistant Professor of GM University. So these are my teammates Samina, Shalini, Sandeep, myself, Varsha, Shreya. Our PBL project contents are introduction, literacy survey, objective, scope of project, software hardware requirements, system architecture, expected outcome and conclusion. So go through our project. First, introduction. Increase in mobile usage lead to the higher power consumption. Day-to-day life, we are using mobiles frequently, so it's not compatible with our project. Increased mobile usage lead to the higher power consumption. Day-to-day life, we are using our mobiles frequently, so power is not capable for our supply. Our demand is high and power capacity is low, so we are frequently charging it. So conventional chargers causes energy wastage. The chargers, normal chargers are frequently wasting our energy. IoT enable and smart automated power control. We are building a device that automatically cut off the power. The project focus on intelligent charging with a monitoring and billing. We are charging and also billing the amount for a per percent by 50 rupees. Literature survey means previously how many similar projects are done. In 2021, IoT enabled battery monitoring for a smart home is proposed by A. Sharma and R. Patil. And next, Wi-Fi based automatic charger with a real-time alert in 2022 proposed by K. Mehta and S. Narai. In 2023, Arduino-based solar charging controller is proposed by M. Das and T. Roy. In 2024, smart relay control using Node MCU for auto switch off. This IoT device is proposed by N. Kapoor and L. Joseph in 2024. Next slides are continued by Shalini. Thank you.
Good morning everyone, I am Shalini. So my topic is problem statement. Overcharging mobile device leads energy waste and reduce the battery lifespan and potentially safety errors. There is a need for the intelligent in IoT based charge system that can automatically detect battery level and disconnect the power when charging is completed. Objectives: to design an IoT-based smart charging system and to automatically cut off supply when battery reaches set threshold, and monitoring battery remoting percentage remotely, automatically cut off at threshold, and calculating the charging cost and efficiently power utilization. And scope of projects, and develop an IoT based system auto cut off power after full charge and enabling the real time monitoring through a cloud dashboard, and reduce the power wastage and improve the battery life, and scalable from smart home and future IoT integrations. Next, hardware and software requirements. Hardware requirements are ESP8266 Wi-Fi model and 5-volt relay model and breadboard and jumper wires and ESP 5-volt adapter and cable, and smartphones for monitoring. Next, software requirements: Arduino IDE for coding purpose and IoT protocols HTTP, and Firebase relay time database, and Kodular Arduino apps, Android apps. Next slide continue by Varsha. Thank you.
Hello everyone, myself Prashna. Today I am going to explain about main hardware components of this project. And first image it shows ESP8266 it is nothing but Node MCU, and it acts as a brain of the smart charger, and it has built-in Wi-Fi, and so it can connect to the internet, communicates with the Firebase cloud to get battery data and a threshold value, and it send control signals to the relay module. And the next image is a relay module, and it works like a automatic switch, and it turns changing on a on or a off based on a ESP8266 commands, and prevent overcharging by cutting power then when the battery reaches the set limit. And next slide, this slide explains the USB charging cable connections. USB cable wires, red wires it indicates power, and black wire it indicates ground, and white wire and green wire supplies the data. And in this project, power and ground wires are used for a charging control, and data wires can be used if required for a communication. And this slide shows the real working prototype. Components visible. It is ESP8266 board and a relay module, breadboard, jumper wires, power supply. And working of these components, ESP8266 reads battery and threshold value, threshold data from the Firebase, and relay is triggered automatically. Charging power is cut when the battery reaches the limit. And this slide explains the software platform used. Kodular, a block-based Android app development tools, and it has no complex coding required, and used to create custom apps for monitoring and control. And a role in the project, display battery percentage, and it allows a user interaction, and syncs data with the Firebase in a real time. Here, this slide shows two different Android apps, each with a specific rule. And first, phone one app, it reads a battery percentage of the charging phone and send battery to the Firebase, and shows charging or a discharging status. And second one phone app shows set the charging threshold. Example, we have to set one specific percent like 80% or 70%, and it displays charging cost or a bill, and it monitors charging status remotely.
Hi, I'm Shreya. Now let's see about the system architecture. Phone A sends battery data to Firebase. Phone B sets threshold and views billing. ESP8266 reads data from the Firebase. Relay controls charging power. Here we can see the flow of the process what that goes on. The phone A sends the message to the Firebase cloud, and it is monitored by the ESP8266, and the message which has to be, the work has to be done is sent to the relay by the ESP8266.
Start.
Here we can see at the first step, the upload. Phone A sends the battery level to the cloud. It is uploading of the data, and then this data will be synced by the Firebase cloud. Then at step 3, the charging percentage is compared by the ESP8266, and the status of the charger will be sent to the relay, guiding that relays to cut off the power or to leave that, as the relay acts as a switch. And the implementation, ESP8266 is connected to the relay module, firmly developed under Android IDE. Android app builds using Kodular. Firebase uses it for real-time sync. Firebase syncs the real-time process which is going on in that monitoring phone, which has been connected to the charging. Circuit diagram. Here we can see Android USB is connected to the relay module and the phone one, and relay is connected to the USB 8266, and this side we see the ESP is connected, it is fixed upon the breadboard, and the ESP is connected to the relay module, relay to the charger, and the charge to the USB cable. This is the schematic picture of the circuit picture of our project. Next we see, now let's see the communication protocols. Wi-Fi based ESP8266 connects to home Wi-Fi. ESP8266 gives the facility to connect with using the Wi-Fi. HTTP based protocol is used as there is a Wi-Fi connection. So to connect with the IP of the ESP, we use HTTP protocol, and this is lightweight, fast updates, ideal for the IoT control. And data transmission, we see from phone A to the Firebase, the status of the phone A which is connected to the charger, is the message will be sent to the Firebase database, and from that it is passed to the phone B, and then the condition is transferred to the ESP8266. ESP8266 will control control the situation and sends the message to the relay whether to off or on the supply of the current. And the performance wise, we see it is reliable and highly reliable, we can say. Then we see, now let's see implementation feasibility factors. Analytic power consumption is very low, less than 1 watt. Scalability can support multiple chargers. There is no restrictions about the chargers, type of the charger. Maintenance is minimal, as not such a big components we have not used. Deployment easy, small and portable. The project can be ported from place to place.
Hi everyone, myself Samina Khanna. Let's see the working procedure of our project. First we have connected the ESP with relay module through. Here you can see 3 pins that are VCC, G and D in. We connect the VCC, which is an output pin of relay module, to 3 volt supply or 5 volt supply of ESP. You can see here, this is the pin which I connected. We can connect this to this. And then we have connected the ground pin to avoid the short circuits, and then input pin. Input of relay will be supplied to D1 pin of ESP. This is what the connection between ESP and relay module. Now let's see the connection between the ESP and USB and relay module. These are the NCC, means normally closed. This pin is normally open. This is common pin. We have connected the common pin and normally closed pin of relay module to the USB. This is a power line of USB. Now, stop. We have given the power supply using USB cable through the PC to mobile phone. This phone is charging, and this is the phone through which we can read the battery percentage of this phone. You can see here the battery percentage of phone A is 75%, and it is also showing in this screen, and also the same percentage we can read this from phone 2, through which we can generate the bill. You can see after clicking this start billing button, billing is started. Charging is on. We can monitor the threshold limit using this slider. You can see here how threshold is varying. Let's set the threshold to be 80. Charging is on. Billing is started. Now we have given the power supply of power supply to phone A using adapter of its own phone. Now let's change the threshold limit to 68, which is less than the battery limit. So you can see here relay is off, green button is off. Let's see what are the results. First one, it will monitor the charging current in real time. It will automatically cut off the voltage and stop the charging of phone A. Test case expected and then results. What we test and what we expected and what are the results. First, see the test case. Is charging is started or not? Charging started, at that time current will be high. This will work fast. Battery reached threshold. After reaching the threshold, current will becomes low. It also passed. Relay cutoff, the cutoff voltage will take place. Phone stops charging. It also passed. Cloud update means Firebase updation. Real-time battery data updation is also passed. Manual control means we can manually control the threshold. It also works. Now let's see the performance evaluation. Accuracy is high. System response time is minimum, very less, that is 0.2 second. Energy efficiency is 20 to 30% saved. Reliability 95% uptime. Safety prevents overcharging. Scalability easily expandable. Now let's move on to the limitations and future enhancements. Limitation is it requires Wi-Fi for IoT features. Without Wi-Fi, we cannot connect the ESP to our mobile phone. This is the main limitation of our project. ESP8266 consumes small standby power. It will consume power. It also a limitation. What are the future enhancement? We will add temperature sensor for heat detection. Then mobile payments like phone, we can pay the bill using phone pay, QR codes and so on. AI-based optimization, we will add AI features like AI features, renewable energy integration. These are all the future enhancement we can do. Now come to the final part, that is conclusion of our project. Smart charger IoT system prevents overcharging. It will prevent overcharging. Overcharging in the case of commercial purpose ensures battery protection, automation, energy saving. It will protect the battery life. Automation means it will automatically cut off the voltage once the battery limits reaches threshold limit. Energy saving means power saving. Combines ESP8266, Relay, Firebase IoT Cloud. The proposed IoT-based smart charger successfully automates power control based on battery percentage thresholds. It enhances safety, reduces power waste, and demonstrates the effectiveness integration of IoT technology in everyday applications. We refer these things to create our project. First of all, we use a design and implementation of IoT-based smart charger proposed by A. Sharma and R. Patil. Then we use Arduino official website, IoT platforms like Kodular to build an apps, phone A and phone B. Phone A will read the battery percentage. Phone B will monitor the phone A's charging system. Firebase to collect the data of phone A and to transfer its data to phone B. ESP8266 technical manual. It is used to cut off the voltage. It sends the signal to relay, through which relay will cut off the voltage. These are all the references we refer. Thank you. Thank you.